The first thing to do to attempt the question above is to write out the chemical equation showing the reaction between tetraoxosulphate 6 acid and copper 2 oxide. After writing out the chemical equation, the next thing to do is to ensure it is a balanced one. So looking at hydrogen, we have 2 atoms present in the reactant side. We have 2 as well in the product side. For sulfur, we have 1 on both sides. The oxygen, we have 5 on both sides. So for copper, we have 1 in the reactant side, and in the product side we have 1 as well. So we have a balanced chemical equation. And going back to the question, we have to determine the amount of copper 2 oxide, that is the mass that will be needed to react with tetraoxosulphate 6 acid. So the compounds or the substance we'll be considering or dealing with here is just tetraoxosulphate 6 acid and copper 2 oxide. So before we proceed into determining the amount, we need to know the reacting mass of each of the compounds present. Let's begin with tetraoxosulphate 6 acid. Formula for reacting mass: number of moles multiplied by molar mass. The number of moles here will be the coefficient of the substance in the equation, and that's why we need to have a balanced chemical equation. Let's determine the reacting mass of tetraoxosulphate 6 acid. We know the number of moles, which is 1 from the equation, but the molar mass is unknown, so we have to calculate the molar mass of tetraoxosulphate 6 acid. So a molar mass of H2SO4 will be the sum of the atomic mass of the elements involved. So for hydrogen, we have 2 atoms present, and the atomic mass of hydrogen is 1, so that's 2 times 1, plus sulfur, which is 632, and oxygen, we have 4 atoms present. The atomic mass is 16, so that's 4 multiplied by 16. Calculating this, we have 2 plus 32 plus 64, which is equivalent to 98. The unit you can say grams per mole. So reacting mass of H2SO4 will then be equals to 1 mole from the equation multiplied by 98 grams per mole. So here we have 98 grams. Let's solve for copper 2 oxide. Molar mass of copper 2 oxide. So copper is given to be 64. The atomic mass of copper is 64, and that of oxygen is 16. Adding this, we have 80, the unit grams per mole. The reacting mass of copper 2 oxide will then be equal to 1 mole, the number of moles, multiplied by the molar mass, which is 80, and this is equivalent to 80 grams. Now we've gotten the reacting mass of the substance. In the question is, if a solution contains 4.9 grams of tetraoxosulphate 6 acid, calculate the amount of copper 2 oxide that will react with it. From what we did earlier, we've gotten the reacting mass of each of them. So now, what if we have 4.9 grams of H2SO4 tetraoxosulphate 6 acid? What mass of copper 2 oxide will be needed to react with it? So to get the mass of copper 2 oxide that will react with it, we can use the relationship saying that 98 grams of H2SO4 required 80 grams of copper 2 oxide. So if you have 4.9 grams now, 4.9 grams of tetraoxosulphate 6 acid, we require X. We are making use of X because it is unknown, of S grams of copper 2 oxide. So, and to know X, we'll be making S the subject here and cross multiplying indirectly. S equals 4.9 grams multiplied by 80 grams divided by 98 grams. Calculating this, we have 4.0 grams, and this will be serving as the final answer. So with this, we've come to the end of the solution to the question, and we've gotten the answer to be 4.0 grams. That will be all. Do well to subscribe for more if you find this video helpful.